Hey everybody, it's Mr. Qualls. Today what we're going to do is we're going to talk about properties of reflections. And we have two things that we have as a goal here today with this. What we're looking at is we want to be able to describe the properties of reflections through experimentation, which is what we're about to do. So verify experimentally the properties of rotations, reflections, and translations. And today we're talking about reflections. And within that, we're talking about to describe the effect of reflections on two-dimensional figures using the coordinates involved. So here we have a coordinate plane, and we have triangle ABC drawn on that plane. Now, this is going to be our pre-image, and then the image that we draw after the pre-image and after our reflection is the image, right? So the way that reflections work is kind of like a mirror, and the way that we're going to look at it first is the triangle, like this right here, triangle ABC. We're going to reflect it over what is called a line of reflection. And once you understand what a line of reflection is, this becomes very, very easy because it's just a distance problem. So if we're going to pick a line of reflection for this problem, we're going to pick the line of reflection of the y-axis. So we're going to reflect ABC over this line. Okay? Now, if you've ever stood in front of a mirror, and you should probably every morning, everybody should at least, see themselves in the mirror before they come to school. It always looks, you've probably noticed that it always looks that you are as far from the mirror as your image is inside the mirror. You in the mirror are the image, but you outside the mirror are the pre-image. And the pre-image of you is just as far away from the mirror as the image inside the mirror appears to be on the other side. And if you've ever brought your finger across like this towards something, like a line of reflection, which would be a mirror, and you brought your line out here, your other image would be probably equidistant until you got to the middle and touched. And then as you pulled away, they would be the same distance away as went like that. So the same thing's going to happen here when we reflect over the y-axis. So if I take triangle ABC and reflect it over the y-axis, we're just going to pretend that it flips straight over this line, and everything ends up on the other side needs to be the same distance away from the y-axis. So can anybody tell me how far is A away from the y-axis right now? 3. It is 3. Very good. So what does that 3 represent? What are we talking about, our x's and our y's? What do our x values represent?
It's 3 to the right of 0.
Very good. It's 3 to the right of 0, and this 0 in this case is represented by what?
The y.
By the y-axis. That's right. The 0 here is the y-axis, and the 0 here is the y-axis, and A is 3 to the right. How far to the right is C? It is also 3. Very good. So the x value for the ordered pair where A is going to be 3, and then what's the y value going to be for A? So A is at 3.
9.
Very good. 9. And what is C?
2.
3, 2. Very good. And how about B?
That would be 4. No, it would be 7. 4.
Okay, 7, 4. It's at 7, 4. Now, when I say where's B, a lot of people are like, well, B is out here by 8, but we're talking about the point. Where's the point, right? And it's at 7, 4. So I'm going to mark that down here right like that, and I want you to do that as well. Okay? If you're working on this at home, what you should do is also draw this, all right? So I should have said that at the beginning of that. Pardon me. Beginning of the thing. Now, if I reflect this, when I do over the y-axis, and this is a distance problem about keeping away from the line of reflection, how far does this image need to, or excuse me, how far does the image need to be on the other side of the line of reflection?
The same exact distance as the image.
Yes, very well explained. That was the same exact distance that they are now, right? The same distance now. So, if I take the triangle ABC and I reflect it, and I take this and I reflect it over this way, it becomes A prime, B prime, C prime. I'm sorry, what was that? It's not over far enough. What do you mean it's not over far enough? Isn't what supposed to be 3 away? A and C. So A prime is supposed to be farther away than it is right now? How far should it be? One more to the left. How's that? How's that look? Is it good? Are we good? Okay, so she did the right thing. Checked all of the points before you agreed to it, right? Now, do you think I put that in the wrong spot on purpose? I certainly did. So I do that a lot. I'm trying to get, if you're not paying attention, boom, there it is. So a lot of you are just like, well, I guess I'll just draw it where he said it. That's not what you need to do. You need to be watching what I'm doing. If this is where everything's supposed to be, we got to pay attention to what we're doing. So, can anybody tell me what is A prime now? Why do I have primes on everything instead of just... That's right, because this is our image. And our image gets A prime, B prime, and C prime. Whoops. All right, so B prime, and then I'm going to write down the coordinates. Oh no, my pen just popped open. Come on. So, somebody give us a coordinate for, and I'm going to put a pencil right here because I've got a shadow on the recording. It looks like a dark line, and it's not. There it is. So, somebody tell me, what is the new coordinate? What is the coordinate for A prime? Negative 3, 9. Okay, so this is negative 3, 9. How about the coordinate for B? How about some more people in the room answering the questions?
Negative 7, 4.
Very good. Negative 7, 4. Right. Negative 7, 4. Thank you. And thank you for speaking loudly so we can hear you up here. What is C prime? Very good. Negative 3, 2. Negative 3, 2. Now, do these coordinates make sense? I want someone else to, do these coordinates make sense from what we were talking about before? Because the key before was that these things, when we make our image, it has to be the same distance away from our pre-image, right? So, are these the same distances, and how can we tell other than, yes, sir?
Because they're all the same coordinates, basically, except they're all negatives. The x is all negatives.
Okay, so same numbers for coordinates. This was a 3 and a 9, and that is a 3 and a 9, but the x is negative, right? So what is a negative 3? How does a negative 3 compare to a 3? Same distance away from 0. How do you know that?
Because when you're going negative, it's the same distance as when you're going positive for the number.
Very good. It counts the same way, doesn't it? The distances work the same way. So a negative 3 and the 3 really have a special kind of value, even though they're not the same number. Does anybody remember what that value is called?
Opposites.
Okay, they are opposites each other. So 3 and negative 3 are opposites. Can anybody tell me why they're opposites? Yes?
Because it's 3 from to the left of 0 and 5 from to the right of 0.
Okay, yeah, they're in opposite directions. And what would happen if you added 3 and negative 3? You get a 0. Yes, you get a 0 from them, and that's why they're opposite. If you add a 4 and a negative 5, you get a negative 1. They're not opposites of each other because it didn't result in a 0. So negative 3 and 3 resulted in a 0. 7 and a negative 7 resulted in a 0. 3 and negative 3 result in 0. So 7 and negative 7 have a special value to them to where we know that they're the same distance away from 0. It starts with A. Yes, ma'am?
The absolute value.
Perfect. Thank you. It's an absolute value. So what does absolute value of a number mean? If I say, what's the absolute value of a negative 7? What am I asking you?
How far is one of the 0?
That's exactly. Thank you. And you guys are smart. How far is this number from 0? That's what an absolute value question is asking. What's the absolute value of a negative 7? 7. So, did we do this correctly? Moved it 7 and that one negative 7 over there. We sure did. So, I'm going to redraw this. So, the big idea here is that when you do this, I don't even need to look over here because I know where they're supposed to be. And there we go. Get my, I'd say trusty ruler out, but I don't know if I have an untrusty ruler. You know where you'd get an untrusty ruler?
Dollar store.
Oh, yeah. I have seen some of those. I was thinking about one of the history teachers. Perhaps one of the history teachers
Oh.
give you an untrusty dollar, or an untrusty ruler. Probably an untrusty dollar as well. So here we are. Now, what do you think the next thing that we're going to do is? What do you think our next thing that we're going to do? Now we've reflected this over the y-axis successfully. What do you think we're going to do? What do you think we're going to do? Even if it's a motion, what do you think we're going to do? Some of you guys are answering questions verbally, and some of you are going like, yeah, I think we're going to do this. What do you think we're going to do? Don't know now? Okay, so I brought it over this way. We reflected it this way. What do you think? Reflected it over the y-axis. Now what do you think we're going to do? What do you think?
You're gonna like rotate it so the A is on the bottom and like the B and the C is on the top. I don't know how to say it.
Oh, so let's talk about that for a second. Does everybody see here? When we were doing our translations, right? When we were doing translations before, we had A, B, C, and we translated this thing to the left. Did the positions of the A, the B, and the C change?
Yeah.
Did they?
Yeah.
The position.
Oh.
Okay, so the positions changed. But is the B still on the right side?
Yeah.
Yeah.
No.
So the B is here on the right, and the B is still on the right.
No.
And the A is on the top,
Now.
and the A is on the top.
Oh, no.
When we were doing translations, yes. However, when we were doing our reflection now, and this moved over here, is the A still on top?
Yes.
Yes. Is the B still on the right side?
No.
No, it's on the left now. And the C is still on the bottom. So why did the B change from the right side to the left side? That's right, it's the opposite. It is the distance now that counts, not just the distance that it's moved. So how far was the A moved? Somebody tell me, how far did A move in this case? 6, right? How'd you get 6? Very good. 3 on each side. How far did the B move? 14. 2 times 7, right? And then C moved 6, which is 2 times 3. So in a reflection, you can't just slide things over. That's what translations are for. So in reflection, sometimes things change position just a little bit. So I'm going to ask this one last time, and I know somebody had the answer right the first time, and I didn't get it the second time. I just reflected over the y-axis to see what happens to x and y values in the coordinate plane when we do this with a figure. Now what do you think I'm going to do? Yes? I am. I'm going to reflect over the, very good, the x-axis. So now what we're going to do is we're going to take this and we're going to reflect it over the x-axis. does anybody, before we draw them, everybody up here again, before we draw, does anybody want to speculate as to what the numbers involved with A prime are going to be when they come down here? What do you think?
Are you talking about the A prime prime? Or
Yes, because now we're going to have A with a second prime on it, aren't we? We're going to have A prime prime.
Or
So-
the like number sometimes.
That's what I want. How are the x, y values going to be affected? What are they going to be when we come down here for A prime prime? They are. They're going to be negative, negative because we're in the third quadrant. Very nice. And what else is going on? Do we know what values they're going to be before we draw them?
3.
Okay, so the x value is going to be negative 3. And what is the y value going to be? Does everybody see that right there? That thing's, yeah, it's just going to be negative 9. It's going to come down here. It's going to flip over here. And if the x isn't going to change, but the y is going to change this time, it's going to just become its what? The 9 is going to become its, starts with an O. No, I'm just like, don't put, yeah, I got it on that. What I'm talking about is the 9 right now. So I know the picture looks a little funny right now. That's not what we're concentrating on. We're concentrating on what the questions I'm asking are and the answers to those questions are. Maybe if I stood here, okay? What is this 9 going to do? What's going to happen with that 9 when I reflect it down here? Yes, sir?
It's going to become negative.
Yes, because negative 9 is
Opposite.
opposite of 9. That's right. It's going to be negative. It's going to be opposite of 9. So it is 1 too low, isn't it? Thank you. Now, I do need to be corrected with that every once in a while, and I do appreciate it, like I said before. But when we're talking about something, that we're talking about the numbers, I kind of get fixed on that one thing, right? So, I'm going to draw this. I'm going to take that picture away, and then I'm going to redraw it. So 2 down, and then 9 down, right? And then I'm going to take this, and I'm just going to go 4.
No, 3. Oh.
So all I did when I was drawing this is I thought, well, that C prime is 2 up, so I'm just going to put C double prime 2 down. Whoop. 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 And there we go. And there's A double prime and B double prime. So over here I'm going to